Hello and welcome back. Today's video is going to be a little bit different from our usual format. Today we are asking artificial intelligence for help with electronic problem and it goes bad, we mean, really bad. So, let's see how AI has epically failed us. If you enjoy practical electronics tutorials like this one, please subscribe to the channel. Don't forget to like the video and enable notifications so you don't miss future projects. Thank you. When dealing with transistors in general, and amplifiers in particular, one of the terms that usually comes into play is small AC signal. If you are not familiar with this subject, most of amplifiers work with DC power sources, batteries for example. So, why do we mix DC power source with alternating current signal for amplification? Shouldn't we use AC power source to amplify AC small signal? It's only logical, right? Well, transistors, the main building blocks of every amplifier, are not designed to work with alternating current power sources, only with direct current ones, like batteries and alike. So, only solution is to somehow shift AC signal into DC domain, and amplify it that way. This process is called DC offsetting. The idea is, to add DC voltage to AC signal, thus pushing entire AC signal into positive voltage region. If we don't do this shifting, then entire negative part of AC signal gets lost, because transistor cannot deal with negative part of signal amplitude. So, our question to Chat GPT was, how can I offset AC signal with 2 volts point-to-point amplitude, by 1 volt, so that our entire AC signal now swings in DC domain? And here goes everything that is wrong with Chat GPT and electronics. The answer it provides is to use operational amplifier in summing mode, thus summing 2 input signals at non-inverting input, grounding inverting input, and at output, voila, we have our sine signal shifted by 1 volt. Okay, so let's draw the circuit that this genius is proposing. We have an E5532P operational amplifier integrated circuit chip. It has inverting and non-inverting input, 2 terminals for power supply and output. The concept of operational amplifier is that it compares signal level at non-inverting input to the one at inverting input, and if signal is greater, it outputs voltage at positive supply rail, and if comparison is negative, it outputs voltage at negative supply rail. Pretty simple and quite effective. What Chat GPT proposes is to ground inverting input. Next, at non-inverting input we sum our AC signal with positive 1 volt, via 2 identical resistors. And at output, we should have our AC signal shifted upwards by exactly 1 volt. In essence, our entire AC signal should now be in DC domain. Now, if you have seen this configuration before, it is correct. In principle, the operational amplifier should add 2 signals at non-inverting input, and output their sum at output terminal. This is how it should work. Every tutorial about operational amplifier in summing mode tells this exact story, and proposes this exact circuit. Well, surprise surprise. It's not working. Instead of shifted AC signal at output, we get square signal that swings from positive to negative rail of operational amplifier power supply. We asked Chat GPT to draw us a circuit for proposed solution. Here is what it generated. Well, let's analyze what is wrong with this circuit. We apologize. Let's analyze if there is anything correct with this circuit. Would you be surprised that the answer is, nothing. Everything, but everything is absolutely wrong with proposed circuit, and here is why. First, let's analyze proposed mode of operation. The idea that Chat GPT has is to sum signals at non-inverting input, by using summing configuration of operational amplifier. Okay, so let's take value of 5 distinctive points of our AC signal. The first point will be at the start, 0 volts, next will at maximum amplitude, 1 volt, next one at middle of the signal, again 0 volts, following with minimum amplitude at -1 volt, and at last, the end of the signal, again 0 volts. Let's sum those points with 1 volt DC offset signal. The resulting values for 5 distinct points now read from +1, up to 2 for maximum, back to 1 for the middle, down to 0 for minimum, and again 1 for last point. So far, so good. Now, let's compare these 5 points with reference voltage at inverting input, that sits at ground level. The operational amplifier will apply the logic as it is designed to do. It will compare signals at input terminals, and output appropriate rail supply power voltage at the output. It is designed to do this. So, it will compare value of 5 reference points and conclude this. Points 1, 2, and 3 are bigger than 0, so output plus VCC, point 4 is equal to 0, so output negative VCC, and again, for point 5 it will output positive VCC. So, if we were to hook up our oscilloscope and take reading, we would get signal like this. This is nothing what we expect at the output. First, Chat GPT is based on Large Language Model, or LLM for short. LLMs are statistical models. They determine how frequently words appear next to one another in the sentence. For example, in most literature you get words South and London together frequently. Same goes for North and New York. In first iterations of Chat GPT, if you would ask it, which city is northerner than other, it would answer, New York. It statistically determined that word North more frequently appears together with word New York, so it hallucinates that New York is more to the north than London, just because of the statistics and frequency of two words appearing more frequently together in literature, that LLM model is based upon. It doesn't understand geography, longitude, and latitude. Its answer is based on pure statistic. So, how did ChatGPT solve our inquiry? It recognized token words like signal, DC offset, summing, voltage, operational amplifier, and etc. In literature these words are keywords for any schematics where operational amplifier is configured in summing configuration. Words such AC small signal, current, and feedback resistor do not appear with high frequency as keywords in those texts. So, it mixed all high-frequency words, from all those texts, and provided us with solution that it thinks contain all the right words at high frequency of occurrence. It simply assumed that AC signal is as same as DC signal, because of frequency of word signal. It did not take into account that operational amplifier sums currents from those input signals, not voltages. Voltages in parallel cannot be summed, since 2 points in parallel has to have same voltage, otherwise laws of electronics fly out through the window. Also, since feedback resistor is implied in almost every operational amplifier schematic, ChatGPT totally ignored its existence, and did not include it in any calculation or schematics, due to small frequency of its appearance in written texts. The role of feedback resistor is paramount in this scenario, as it provides feedback from output, to level up all the summed currents from input, in compared to virtual ground at inverting input. And at last, in this configuration operational amplifier can only sum DC signals, or to be more precise, it can only sum their respective currents. Summing AC and DC voltages is achieved through capacitors, not operational amplifiers. What an epic failure for artificial intelligence in general, and ChatGPT in particular. When confronted with its failure to provide meaningful solution to the problem, it started to spew more hallucinations that made no sense whatsoever. Here is the reply. The rest of the conversation is just regurgitation of nonsensical ideas how to add AC and DC voltages, which we just explained is impossible for operational amplifier in this configuration to do. So, if you want to learn about electronic the right way, Don't ask Chat GPT or any other AI iteration of the same open-source large language model. It simply cannot provide correct answer, because it is not capable to do so. Instead, subscribe to this channel, leave a like, and share the videos with others. Thank you, and see you next time. Bye.